welcome to this lesson. So in this lesson, we want to look at the zero index law and the negative index law. So be looking at number one, zero index, which says that any number raised to power zero equals to one, and then the negative index law says that when you have a number raised to power minus one, whenever you have negative index, you change the minus to 1 over what you have, okay? And then we can also have it in the form of a raised to power minus n equals to 1 over a raised to power n. So you change the minus to 1 over the base raised to the given power. So the negative change to 1. It is also called the reciprocal law, okay? So this law can also be extended to this formula here. Okay, we are going to explain that, or let me just quickly explain that briefly. Okay, so what are we saying? A over b raised to power minus n. Okay, whenever you have a law like this, you know that negative will change the base to will change to 1. So you have 1 over a all over b raised to power n, okay, and then you apply the product law here. That will be 1 over a raised to power n over b raised to power n. If you apply the fraction, division of fraction, a over n over b raised to power n, turn it upside down and change to multiplication, we have b raised to power n over a raised to power n, which is equals to b raised to power n all over a raised to power n. So in short, whenever you have this expression raised to power n, the minus we invert the expression inside the bracket. The minus will turn the bracket upside down. Then you have b raised to power a, b over a all raised to power n, and then you can now expand b raised to power n over a raised to power n instead of, so it's a shortcut, so it applies, okay? So now let's look at our examples briefly. Examples. Simplify the following, giving your answer in simplest rational form. So for number one, 5 raised to power 0. Any number raised to power 0 is 1. So 5 raised to power 0 is 1. Number two, we have 5 raised to power 0 minus 5 raised to power minus 1. 5 raised to power 0 is 1. 5 raised to power minus 1 will be 1 over 5, right? And then if we simplify this, we have 5 minus 1 all over 5, which is equals to 4 over 5, okay? And then this one, remember what we just analyzed, the minus will turn the fraction upside down, so that will be 5 over 2 all raised to power 2, and then you can now apply the product law. 5 raised to power 2 all over 2 raised to power 2. 5 raised to power 2 is 25. 2 raised to power 2 is 4, and then we have 25 over 4. So this is how you apply this negative index and zero index. Now you're going to pause the video and answer the following questions, okay? So examples, activity or classwork. Simplify the following. A, 7 raised to power minus 1. B, 3 raised to power minus 2. And C, 3 over 11 raised to power minus 2. Good one, guys. So let's solve it together while you mark. A, 7 raised to power minus 1 is 1 over 7. B, 2 raised to power minus 2. Change the minus to 1, so that's 1 over 3 squared. 3 squared is 9, so that will be 1 over 9. Remember, your answer must always be in simplest form. 3 over 11 raised to power minus 2. That will be, the minus turn the bracket upside down. 11 over 3 raised to power 2. So that will be 11 squared all over 3 squared, which will be 121 all over 9. And then, or you can't leave it like that. The numerator is bigger than the denominator. So 9 in that is 9 times 9 is 81, right? 9 times 10 is 90. 9 times 11, 99. 9 times 12, 208. 9 times 13, okay, 108 plus 9, that will be what? So this is 10, 17, 117, right? 117. So that this answer will be 13 O number, 121 minus 117. So that will be 4. 13 O number 4 over 9. So that is the simplest one. Remember, when you have your answer as an improper fraction, you have to always simplify and change to or mixed fraction. So if you get to correctly mark this one, so this is 1 mark, or mark this 2 marks, mark the steps here, turning upside down, that's 1 mark. Simplifying to this place, that's 1 mark, and the final answer 1 mark, and give yourself 5 over 5. Okay, good one. So in our next lesson, we'll be looking at rational and fractional indices. See you then. Bye.